Welcome to another semester of the virtual quantitative marketing seminar. We have a really exciting slate of speakers. And as a reminder, the format for the seminar is ask questions using the Q&A feature, and we will ask them on your behalf at an opportune time. And feel free to stick around towards the end for a more free-flowing discussion. So with that in mind, we're very, very honored to have Colin Camerer tell us about his model of a neural autopilot analysis of social media engagement. Why don't you take it away?
Good. Thanks so much for having me. I love these formats, and you're a perfect audience, I expect, for helping us figure this out. So this is a project with a lot of people. Yi Xin is the first author in the kind of lab model. We're in sort of lab model. So the first author does most of the work and has the biggest career concern. And the last author just like supervises and herds cats. And Matt Chum, many of you know, is a senior IO economist who's really terrific. Okay, the background is this paper. This was a chapter written for a book that took a long, long time to get assembled. And the main drivers were Peter Landry and Ryan Webb. Ryan is going to talk to your group in April about this very similar model, so you get to see two glimpses of the model based on different data sets. Okay, so the basic idea is a lot of decisions are habitual, and by that we have a neuroscientific concept of habit. It's not a Beckerian or kind of econ marketing concept. Habitual means often cued by some kind of state variable, like drug cravings is the most extreme example. Largely automatic, and low effort, the background is I just told you. So we're very influenced in our economics by what's David Marr, who had a very famous 3-level model of, in his example, workhorse example, was a vision. And the idea is a good theory should be able to tell you what a behavior is for, a behavior or a system. Like, what's the adaptive purpose? What computation is it making? It should be algorithmically specified so we can kind of inspect the math and discipline the theory and communicate about it in the language of mathematics. And this is unusual for market economics and social science outside of psychology. And we should also understand the actual wetware, the implementation. How is this implemented early? So we're trying to do all three things. And I understand that's unusual, but that's what we do. Okay, so what is habit for? And the answer is to make fast choices that are again highly automated and low effort when rewards are reliably predicted. So there's not much of a cost to making the fast choice. And the only kind of bug is that if some other reward has become valuable in the habit model, as we specify it, you can put in more tweaks, we'll kind of stick with a bad choice too long. It's not forward-looking, it's not fully rational. And so that's the price you pay for the economy. And how does it work in the brain? Quite a bit is known about that. I'm not going to show you any brain pictures, but there's, for example, there's evidence from rats where you lesion dorsolateral striatum or medial striatum, and you can either abolish habits so the rat no longer act habitually, or you can abolish what's called goal-directed, more rational behavior. So the animal evidence is very strong. And the basic idea is this, which is that there's kind of two modes of decision making. It's akin to fast and slow, but it's just special. In habit mode, you're going to repeat the choice when reward is predictable. So the reward reliability is going to be a number you compute, which is basically the absolute value of prediction errors. And if that's below some threshold phi, which you could think of as an index of how habitized the person is, low phi means not very habitized, high phi means very habitized, you're going to just repeat the choice. And the opposite is goal-directed mode, which is basically utility maximization. Okay, so Gary Becker, in writing about this a few years after his famous paper with Kevin Murphy, said, I believe the main reason that habitual behavior permeates most aspects of life manage in the biological evolution of human traits. So Gary is on board with the top part of the Marr hierarchy, right? That we should have some inkling of what it's for, but he doesn't say anything about real biology besides using the word biological, and that's what we're gonna say. So, in some ways, I would like to think Becker would look favorably on this. That we're trying to actually kind of honor and cash in on his quote. Okay, a very classic result we're going to see in a minute is from Adams and Dickinson, Tony Dickinson, and many later papers, including Bernard Berlin and my Caltech colleague John O'Doherty, who's one of the world's experts on this. And the idea is that you kind of overtrain the rats to press lever for food, or overtrain humans to move a joystick to collect valuable coins. And at some point, you devalue the reward, and rational animals would quit working. Working means something effortful like lever press, but they continue to work for devalued rewards. We'll see more in 1 minute. And Graybill and co-authors, starting in '99, were able to do single unit intracranial recordings of highly trained rodents. And what happens is they show activity when you initiate a trial, like running down a maze to get a little bit of food, but they don't show much neural activity in response to actually getting the reward. So the reward signal comes in like, oh, I'm about to get food, because they've overtrained and learned. It's as if the act of running becomes valuable, because they know in their little rat brains that it's going to lead to food because of Pavlovian association. And if you want to dig deeper into the neuroscience, which we're not going to today, Lee and colleagues have a paper on what's called arbitration, and their idea, which is similar to ours, but I think maybe wrong, is the brain keeps
Colin,
track of
you're
the
breaking up a
reward
little
reliability.
bit. I don't know if there's anything you can do to if you have any options on your end, but you just.
Oh, really?
Yeah.
I do not.
I mean, assuming other people are experiencing that, not just me. Yes. Okay. Everyone's nodding. Yeah.
Oh, really? Oh, gosh. Let's see. The internet looks pretty good here.
Well, yeah, it just seems to be in sort of
frame.
fits and starts. You were fine for a bit, and then and then not, and then etc. So yeah. Steve Tadella says it must be the warm LA weather.
Yes.
Yeah. Oh no.
Why don't we? So I don't have any great options. I'm as close to the internet.
Okay. Well, yeah, we can just carry on, and if something really breaks up, we can.
And just if it breaks up, just remind me, and I'll rerun the tape, and I'll try to go pretty quickly. Okay. So here's a graphic from the Adams and Dickinson. This is a generic kind of result. The rats undergo instrumental training. Instrumental is what we call active learning. It means that they respond and they get a reward, respond, reward, and they learn to mentally associate those. And they're getting these food pellets. And the outcome evaluation in this case, it's been done in a number of different ways, is that they then get to freely eat pellets, but they're laced with a harmless but bad tasting toxin, so that they develop a very rapid taste aversion. Like, ugh, I don't want to eat this stuff anymore. And then they go back in the test, and the test is, do they keep pressing the lever to get food, which they don't like anymore? So the food has been devalued in this biological sense. With humans, it's like you give them M&Ms and they just eat as many as they want, and presumably they're satiated and they don't have any marginal utility. And so with moderate training from the test session, with moderate training, the control, which does not eat devalued food, presses about 7 times per minute. And the devalued condition rats press less, about 3.5. Okay, and so this gap, you can think of the gray bar in moderate training as is still a little bit of habit. They keep pressing even though they don't like this food. And the gap between the white and gray is what's called goal directed, is that part of the brain, dorsomedial striatum, knows that the food's no longer valued, but they keep pressing anyway. Okay, so this is going to be the key concept of habit, is they continue to press. And with extensive training, I think that's 500 trials versus 100 or something like that, you see very little difference. So there's 2 rats. One of them likes the food. They press and eat, press and eat, press and eat. The other rats like presses, doesn't need food. They keep doing the habit. And it's related to something called action slips. Action slips, right? Like we have 2 SUVs at home, and one of them has a new electronic key, and the other one you have to put a key in the starter. And when I toggle back and forth, when I get in the one that has to put a key in, I keep pressing the non-electronic starter button, because I'm slipping over the action from the one car to the second car. So you see these in kind of everyday life, and this is sort of the hallmark of habit. Okay. So what we think of as the standard model in economics and to a large extent in marketing is that past choice increases the utility of future choice. And that's accompanied by empirical evidence of choice persistence. You know, the best way to predict what somebody will do is just predict what they did last time in consumer purchases and lots of other things. And the reason is the economic argument is called adjacent complementarity, just like consumer good complementarity, right? Like bread and butter, hot dogs, and mustard, is that yesterday's choice may be adjacent, like intertemporal complements. Okay, and as I understand it, which is not at expert level, in marketing, they're kind of related concepts like inertia, brand loyalty, state dependence. There's just a name for some preferential structure. Okay, and there may be small differences among those, which unfortunately I don't know much about, and I'm going to therefore ignore. But this again begs the question, which we care about, and Gary did. What is the biological mechanism? Like, what would cause this choice persistence? So we're going to propose a very different story than adjacent complementarity, although that's going to be evident. You can have both, right? Why not both? You can have adjacent complementarity type story and neural autopilot. And our answer is that choices persist, not simply because people prefer to do today what they did yesterday, but because what they did yesterday was a marker of reliable reward, and they continue things that are reliably rewarding. Okay. So here's a quick example that some of you might know that's very clever. So Larcombe et al. In the paper in the QJE, they exploited the fact that there was a strike in the London Tube, and so people had to find a new route, either a new tube route or they had to get off early and walk, etc. And about 5% of the London Tube commuters, using Oyster swipe cards, they could tell kind of where people went every single day and identified them. About 5% of them found a better route after the strike. And they could have found that better route themselves, right? The strike kind of provoked it. And by the way, is 5% a big number or a small number? It seems like kind of a small number, right? So it may be that a bunch of commuters found a better route, and then sort of like the rats went back to their old inefficient route because of habit, or it could be that there's a lot of other things. So maybe they meet friends on the train, etc. Okay. Anyway, about forced experimentation, which is how we think about the London Tube case. So in the pandemic, people did a lot of things differently because opportunities, costs and benefits changed, and they may have learned that things that were previously foreclosed because of habit, stickiness, or inertia were now good ideas. And so we're interested in the question of whether these changes will persist after the pandemic, and does forced experimentation lead to like a new habit, and how does that work? Really, we wanted to use this neural autopilot model and kind of train it on a data set. And we happen to have these data on social media. Ryan Webb, as I mentioned, we'll talk about tuna instead. Okay, so we scraped data from Weibo, which is a Chinese version of Twitter. And so we have a lot of timelines of postings and activity on the platform for about 20,000 people. I realize with big data, that's actually not that big. And the beauty is that they had it in different areas of China where people just couldn't go out, and they would have food delivery, et cetera, or they'd go very occasionally to the store. And so we're going to see the same people before and then during and then after the lockdown, and see if there's some kind of changes in habit. And a really crucial thing for understanding these models is reward. Like, we want to be kind of close to the rats in the lab, right? And so we're going to use likes from your I'll call it a tweet, but it may have a Chinese name. We're going to use likes as a kind of a measure of reward. So what people are learning the value of actions. They have no preferences. They're learning value, subjective value, right? And what they're learning is the value of likes. Okay. That's not a great measure of reward compared to the lab. So I like to, in my research, often toggle back and forth between field lab. So every time we just field experiment like this, I think we can control subjective value, right? Like food or drink, because likes is very noisy, but that's what we have. Okay, and we're going to divide the data into two different groups called early adopters. Those are people who were on Weibo before the 2020 lockdown, and then late adopters. And those are people who started using Weibo at the beginning of the lockdown. So they're kind of forced to experiment and do so to keep in touch with friends and news and things like that. And the main analysis is pretty straightforward. We're going to fit the neural autopilot structural model to posting rates. So we're going to try to predict whether an individual posts on a certain day. That's going to be the unit of data for the 20,000 people. Okay. First thing, just to give you some numbers to fix in your head. We basically called out a lot of people who don't post very frequently, which, as you can imagine, many of you know, for these social media things, there's often a huge right tail that a lot of people are doing most of the action, and people get on and they attrit and don't use. We have on the order of a year of data for the lates and 3 years for the early adopters. They don't post too often. It's 8 or 10% of the time. These are reposts and things. The average likes received is also very sparse. It's mostly, the median might be 0 or 1. And so they're typically not getting a lot of likes. There's a long upper tail. It's a minority male, around 30 or 40%. There are some official accounts, but that's pretty rare. And then most of the users are not from very developed areas like Beijing. Okay, so here's the guts of the model. So we're going to model the agents as choosing from posting or not posting. And not posting is outside option, like doing something else. Okay. If they're in habit mode, they just repeat the choice. If they posted yesterday and they're in habit mode, they post again. Otherwise, in goal-directed mode, they use some noisy softmax utility maximization. So we want like hardcore standard utility maximization to be the model of goal-directed. And that also means that empirically, we can turn off the habit mode parametrically. We just set this phi number to be 0, and you can see what a full rational model looks like. And the core thing, which is maybe unusual for many of you, but very, very central in neuroscience and neuroeconomics, is the reward prediction. Okay, so let's see if this works. Great. So these are just simple difference equations. You can, and people have done this in a Bayesian way as well, but we just didn't do it that way. And the idea is that we're going to keep track of 2 numbers for the posting, which is the reward value of posting, which is just going to be the lag reward value plus the prediction error times a learning rate. This is what we call reward prediction error, which is the utility minus the reward prediction. And again, you should think of utility here as actual reward. So they're kind of learning about utility. They're learning how many likes they get, right? This is not revealed preference. It's learned preference or learned behavior. And if they do not choose that action, they just keep the same reward prediction. It doesn't decay or anything. And the more important variable is called D for doubt stock. So Peter Landry, kind of Chicago-y, wants to call everything a stock, like in Becker Murphy. So the doubt stock is a decayed lag doubt stock plus the absolute value. Notice brackets on top, absolute value, sometimes called the unsigned prediction error, right? So if the difference between your reward prediction R and then the outcome is high, that means the doubt stock is high and reward's kind of unreliable. You're not getting the same amount of likes each time. If that doubt stock is low, that means you can be pretty sure what the absolute value of reward prediction will be. And you could well imagine that you might want there to be 2 different learning rate parameters, lambda sub D, for positive and negative. Like maybe you react more to positive reward shocks, reward surprises, than negative rewards. And we have an experiment with that, but that's a very sensible intuition. And if the action is not chosen, then the doubt stock kind of drifts up by this factor lambda D. So there's going to be some steady state of the doubt stock. And the model's pretty simple, which is when the doubt stock is below phi, you're in habit mode. So the agent wakes up, they think about Weibo, what did I do yesterday? Was it reliable? If it had a low D, how low? Below phi, which we're going to estimate. If D is below phi, they do the same thing. Notice they don't even have to think about the utility, right? They just think about the doubt. What did I do? Was it reliable? And so if you ask them a question like, why are you posting on Weibo? I don't know. I posted yesterday and it worked out great. Pretty much like I expected. That's what their little explicit brains would say. And
one question about the reward is, how important is this parametric specification of the reward? And maybe that gets to some of your, the downside of the field here, is that it seems like if this is set up to be
Very
say,
important.
linear in the number of likes, we might think that there's huge diminishing returns from likes. And if you misspecify that reward function, you then get things that show up.
That's a very good clarification. It's really crucial, and particularly here because you have this long tail. So I think we experimented with log, like the log of likes, but it may well be that it's just 0, 1. Like if you get any likes at all, it doesn't matter if it's 1 or 5 or 10. I mean, empirically, right? Who knows? So it's very much like feeding the animals food, right? You give them the 3 pellets or 1 pellet. It's about concavity or linearity. We have not experimented with that too much. And again, I think something like tuna is a much more kind of congenial test case. You have you buy 1 can and you eat that in a week or something like that. The number of likes, and we also don't know, who made the likes could make a difference. It could be the time course at which they arrive makes a big difference. If it's a steady drip over a couple of days. So there's a lot of important progress you can make in kind of really unpacking that U, because that drives the whole thing. And so if the U is misspecified or has some interesting structure, we're not going to get quite the right answer.
Yeah, I mean, certainly we know that at least some social media companies try to sort of make sure that everyone gets at least a little bit of feedback.
Yes,
and
we're going to talk a little later about counterfactuals. If we manipulate you or in some way, would interesting things happen according to the model, right? So in a way, we're going to do a thought experiment of exactly that kind. And let me just draw your attention to these lambdas. These are called learning rates. The lambda R is the learning about the reward prediction. That's going to be low, like too low, unfortunately, or at least too low compared to a lot of other data sets. And then lambda D is the learning rate about this reward reliability, which is going to be higher. Okay. And so as I mentioned, when reward is sufficiently reliable, the D is below phi, you're in habit mode. When D is above phi, you're in goal-directed mode. Okay, so here's a blizzard of numbers. And again, we're going to do this separately for early adopters and late adopters. Late adopters are a little harder to predict. Their profiles are quite different. The learning rates are pretty low, like 0.01. Usually in lab experiments where what you're learning about has like a restless bandit is called, where you're doing like a bandit task, but the rewards like drift over time statistically, you get numbers from like 0.1 to 0.3. So these are lowish. Lambda D is a little higher. That's interesting. I mean, no, this is other than the tuna study, this is the first study that had looked at these 2 different types of learning rates. And it looks like they're adjusting the doubt stock learning much more quickly, which is probably a good feature if you're trying to not get too stuck in habit, right? What that means is that if you post a bunch and you get an unusual number of likes, you're going to move out of posting habit mode more quickly. Kappa is a switching softmax parameter. Forget that. Phi is the threshold. You can see it's way above 0. So that kind of rejects a strong form of irrationality. And so is a number that adjusts the habit threshold for different categories. Is not very interesting. And then these are the estimated U zeros. That is the initial utility value. Oh, sorry, this is the utility value of the outside option. We allow that to vary, and the utility value goes down a little bit during the lockdown and after. And we have not done more on trying to estimate fix these. Okay, pause for questions about neural autopilot, which is very complicated. This young man is facing a complicated task too. So I kind of sketched the moving parts and showed some notation, and then one batch of numbers, and the rest is going to be showing you some graphs.
Just and maybe this will be answered, but just so I'm kind of understanding, what we should be expecting is when somebody sees way more likes than they expect, or way fewer likes, then in the next period they're much more likely to not be in the habit mode. But then what they do when not in the habit mode is conditional on the sign of that error. And so I guess I'm just trying to think about this question of how the misspecification of the model would would matter for this quantity? Like, how sensitive is this all to sort of getting that exactly right? You know, if you were to misspecify the model for utility for the utility, do you end up, you know, saying that there's habit when you've generated the data from a model?
That's a
without
really
habit
good
at all?
question. I'm really glad you asked that, because I hadn't thought of it in quite those terms. My hunch is that if you misspecified utility, it means your reward prediction error structure is wrong, and you're gonna think reward prediction errors are low and high. Your intuition's right. We're gonna overascribe people executing habit versus not executing habit. But I'm not sure. We'd have to think more carefully about that. And, you know, and I should add just as a at this point. So as neuroeconomists, we actually think there's a whole bunch of ways you could measure whether people are in habit mode. For example, reaction time, like do they post quickly? Declarative memory, which basically means if you ask them, like, did you post yesterday? In habit mode, you may forget, because the whole point of habit is to economize on attention and effort. So they may be forgetful. Like there's some studies of, you ask people how often they check their phone, you know, and they say, oh, 20 times a day, and it's 50, right? So in habit mode, you might be kind of forgetful, because that's what habit's for. And again, it's sort of a bug if memory is important, but that's just the price you pay for the economization. And I think, although it hasn't been explored very much with any species, is multitasking. So when you're in habit mode, you might be able to like post on Weibo and then have a conversation, just like you can drive your car, listen to the radio, or talk on the phone hands-free, right? So these are like in the lab, we could do all these things, right? Where people are doing some activity, we either habitize them or don't habitize them, and then we measure, you know, the ability to multitask, their memory for what they did, and so forth. And the idea with this is that habit sort of like degrades cognitive performance, but that's its purpose, is to save cognitive effort.
We have one question from Aishwarya, which asks about what's the intuition for the lambdas decreasing during the pandemic and lockdown? Is that just a nuisance that you need to fit, or is that part of what you expected from the theory, I guess?
That's we wanted to sort of give some flex. It's the utilities of not posting that change. Yeah. And so we wanted we just wanted to put some flexibility in there. I mean, you could certainly, I think Yi may be working on this like as we speak, you could certainly like fix the U's to be the same all the way through. But we just wanted to put in, during the pandemic, people were really at home, right? And so the idea was maybe the utility of not posting, like what am I going to do instead, goes way down. It just seemed to go a little bit down, or maybe it goes way up because other than posting, I find some other exciting thing to do at home. You know, they're watching more YouTube or TikTok probably, and we just wanted some flexibility about that. It's a little risky, right? Because then you have to try to interpret, you know, did the U's go down for the right reason? Is there a misspecification that's creeping in? But we can always fix those and see how it makes the fit. Okay, great. Let me move on from this.
I think there's actually just a couple more questions, if you don't mind.
Oh yeah, okay.
Yeah, and I think this is kind of about just, you know, the different behaviors on social media. And so, I mean, the thought I had was a lot of what we might worry is most habitual is consumption or propagation of other people's content, and because especially since those happen a lot more frequently than posting. And Jeremy Yang asked, kind of related to that, it seems like one of the reasons that people would post is actually to sort of gain and retain their audience. And so they might actually be thinking of the rewards as the growth and retention of their audience, like how many followers they have. And just in general, my intuition would be that somehow posting may be much less habitual than consumption or reposting or liking. And I just wonder if that's something you think about in terms of the reward structure for posting, and also whether maybe there's other behaviors to look at here.
Yeah, that's a good idea. We can do more with that, right? I mean, it may be, the models are pretty general about what's driving reward learning, right? It could be growth rate rather than likes. It could be some nonlinear function of likes. I mean, we can try a bunch of different things. Again, most of the people post not very often, as you saw in the summary statistics, like 10% of the days, and they don't get a lot of likes. And we have looked at the quantiles. So it turns out that like the top 10% of posting and likes, there's just much bigger numbers there. We have not parsed whether like the model fits those types of people better or not. And that would be an interesting thing to study too. And maybe that the heavy posters are more habitual, even though that doesn't necessarily come out of the model. But habituation should come just from reward reliability.
And just to clarify, then all this analysis is of the heavy posters, because I think you said you started with 20,000.
Oh, this is everybody. Oh yeah, it just cuts out the really rare posters. So okay. The people we retain are still only posting 10% of the days.
I see.
This is not an ideal data set to study Habit, but we have it, and we wanted to see if we could make some progress, and then also kind of what challenges. We're not trying to write. Well, we may be trying to write the perfect paper, but we're not, right? It's like 1.0, and then I think as we learn more about what's driving reward and the apparent utility or the reward updating, we'll be able to do better in other data sets.
One other question, just related to a question that was raised in the chat, but how should we think about the timing of when the reward arrives? So if you get that like immediately versus if I get it like a week from now,
I believe the likes. That's another major departure from the lab rat type model, right? But it's a press reward. It is true that spatiotemporal contiguity tends to promote habitization and learning, right? So if they post and 3 days later there's a bunch of likes, they may not even notice, and the fine details of the technology will make a big difference too. Like, does Twitter alert them that there's a like, et cetera, et cetera. I think we have a short window for registering the likes, and again, most of the time, it probably is true that if there's a lot of likes, they flow in over time, and we're going to just kind of lump them in. In terms of the reward prediction error, I think you could kind of register likes as you go in some way. We just haven't explored that too much. Okay. All right. And so we're going to compare this plain autopilot which has a bunch of numbers I showed you with two other benchmarks. And one is that we're going to include lag choice. So if you're in goal-directed mode, the probability of repeating action A1 is going to be increased by C of t minus 1 is just a dummy variable. Did you do that last period, like yesterday, with a weight gamma? So gamma is going to give us the strength of like the additional predictive power of lag choice. And then there's just a logit model that just has characteristics and lag choice as well. Okay, and so you can see there's no standard errors here, but you can see basically that, so autopilot on its own, it does have a lot of free parameters, but the BIC or AIC correction, it doesn't make too much difference. That has a log likelihood of around 38,000. 39,000. The pure logit is a little bit worse by like 10%. And then when you kind of combine them, and this is the weight on lag choice is 1.334, and that's quite significant. And there's a substantial improvement in log likelihood by adding in lag choice. So despite what I said at the beginning, that we think of neural autopilot as conceivably quite different than persistent choice, because choice persistence is not directly built in to the specifications, right? It just comes in through reward reliability. If your lag choice is reward reliable, you will remake it, but not because of utility, because of low doubt, right? Because of low doubt, because it's the reliability. But when you put in lag choice, just plug it, inject it right in, you do get an improvement of about 10,000 likelihood points, like 2 or 3%. Okay, so it looks like these things probably really coexist. Ryan shows similar result. One thing that's concerning is when you put in lag choice, some of the parameters do move around, particularly the learning rate goes way down, which is not good. That's kind of too low. I mean, it may just be they're learning very slowly because the likes are noisy, or it could be that, I mean, that's the main driver in the model. And the reward reliability threshold also changes quite a bit. We haven't quite figured out why that would be the case. So it knows, it looks like, remember, a high theta means that for a wide range of reliabilities, you're going to be in habit mode. So higher theta is more habit mode and lower theta is less habit mode. And so there may be some delicate identification problem that's kind of buried in there. Okay, let's look at some graphs first. So these are not, if we were faking the data, these would not be the graphs I would show you. So here's the data, and again, they post around 10% of the time. There is an upward drift in advance of lockdown, and it continues to go up a little bit in lockdown, and then it reverts, and it goes back, as you'll see later, it goes back, it's actually a little bit higher. So if you compare the after lockdown to before, it does look like there was an increase, but we don't know if that can be ascribed to forming a new habit. It doesn't look like it's actually forming a new habit. It's just that the utilities of posting changed. Like they tried this new thing and they like it. And the simulated data track that a little bit, but in the first few months before this is the vertical lines are the lockdown period, right? So it's very sharply defined by the Chinese government. You can see that posting started to ramp up, and the simulated data, in other words, we took the fits, and then we just simulate data based on those fits in order to, doesn't do very well. It doesn't show that drift, but it does show an increase during lockdown. So it's picking up this slight increase. It doesn't do it quite extremely well numerically. Another blemish is these are the late adopters. So by definition, on the first day they joined, in the first day of lockdown, the posting is 1. That's how they got into the late category. And so that's going to go way down. And the data kind of goes way down to around 20%. And then you see an upward drift during lockdown, more posting on Weibo. But the model does not pick that up. And then the model kind of tracks the convergence downward after to a really low rate of posting. So unlike, say, the London Tube study by Larkham, these late adopters are not really picking up a new habit. You know, they start out by posting rates fall, and then post lockdown, it's not the case that they say, oh, I learned about Weibo because I was ignoring Weibo, but I learned about it during lockdown. I love it. It's really great. I'm going to continue. 5% of the people are going to continue to use Weibo. It just drifts down and down and down. Okay, now let's compare the different models. So the pure autopilot is red. If we put in the lag choice, LC lag choice, that becomes yellow. As you can see, that doesn't really help explain the pandemic posting and post-pandemic. And the logit actually fits pretty well, except it does something weird, which is the logit is just kind of tracking choice, right? So for some reason, it underreacts to this upward drift. And then it jumps sharply at the beginning of the pandemic, which is not really what the data did. The data just drift up, and there's some spikes of posting. There may be holidays or something. Okay, and that's why when you look at the overall likelihood of this pure simulated logit, even though it's here and here, it predicts this upward. It kind of exaggerates this upward jump, which is not what you see in the data. And for late
that's
adopters,
because the design matrix for the logit includes this indicator of the lockdown period or something like that. Is that?
Yeah, that's right. Yeah. You have a very sharp eye. Yeah, it included a dummy for lockdown.
I see.
So if we turn that off, you wouldn't see the jump, but then it would fit even worse. Mm-hmm. So yeah, it's as if the model kind of uses that as sort of like a chance to reset to where the data are. Because it didn't drift upward correctly. Again, here, the late adopters, you've seen the data before, that's in the blue. The puzzle of this is this slight upward drift and then a convergence downward. And the logit does okay. It picks up a drift in the middle, but most of the models just go down, down, down. They don't really get the main feature of the data, which is this upward drift. I think what's going on is that his likes did not increase during this pandemic period. So somehow people are using Weibo more often, but our reward value, which is likes, is not driving that learning. This goes back to Dean's point, like, what is the true reward specification? And maybe that people are like, are you on Weibo? Oh, I'm on Weibo. Okay, then so activity on Weibo, even absent likes, is somehow socially rewarding, and the model doesn't have that in it. Okay,
and I think related
yeah.
to one of the questions we have is that maybe a lot of the value of using Weibo is consuming other people's content, and so I wonder if you track the likes given by these people, which might be an indication of some of the reward that they're getting, and especially when people, I think about some sort of maybe overblown slot machine to social media feed analogy. What they're thinking about is people keep pulling the lever to see the feed of other people's content, right?
Yeah.
So maybe that's the sort of increased reward during that time.
Yeah, it could be. Unfortunately, I don't think we have very fine-grained data on sort of what they're doing, like what they're looking at and so on, because we're just scraping it. But that's a good point. Yeah. I mean, again, I think unless you have a pretty firm grip on what the reward value of engagement is, this model is going to not be quite right, and it might be way off. So I think it's kind of a shell, like more fine-grained data where you have a better understanding, including maybe self-reports and so on, about what users get value from. That's going to help you a lot in some other application. Okay, we looked a little bit at counterfactuals, which are quite neat. This is something a little bit new to me, strong, but thanks to Yi and Matt Shum. And one counterfactual, these are during lockdown. One that's in red was just to increase reward. Let's say you could just create more likes, like you have a bot that just, like Dean mentioned before, that just likes people's tweets, in some way. And what happens is that does increase posting, and then it decreases, goes back down, and gradually. These are long simulations, right? So we're simulating out 2,000 days, like 5 years. About a year or two later, it's drifted back down. An interesting one is reward volatility, right? Because that's kind of special to this idea of doubt stock. So suppose you could reduce the reward volatility. So what that means is if somebody has a lot of likes, you like insurance, like likes insurance, reward insurance. So if they don't have very many likes, you give them a few, and if they have a lot of likes, you tamp it down. That's going to decrease the reward reliability doubt, and to make it low, which means it's going to be below the threshold fee, which is people are become more habitized. And so that does have a big effect, goes from 10% to almost 40 during lockdown, and then it just wears off again. So you don't really see it long persistent. However, let me call your attention to one, and then another is if you extend the lockdown period. So if you think that there's this kind of learning by doing type of process where when I'm in lockdown, I'm using Weibo, I'm getting a lot of likes, I'm learning to habitize. If you extend the lockdown, you might get a longer habituation, kind of like in the rat study, like moderate training versus extensive training. And that doesn't seem to make much difference. So the extended lockdown is what if it was twice as long. But one interesting thing that's not visually super apparent is the posting rate starts out, again, these are early adopters. So they've been on Weibo before the pandemic, before the started at 10%. By the end, they're up at more like 12%. So there is some sort of long run effect of Weibo, but it does not correspond to habit mode. It's not as if they become habit mode Weibo. It just seems to have to do with the utilities. And so this is Ryan's going to show you a much nicer version of this with tuna. This is the probability of being in habit mode. So one thing we can also trace is not only do they post, how many likes do they get, like are they in habit mode or not, statistically speaking. And so this is the probability that they're in habit mode of posting. And as you can see, they basically never get in habit mode, except in this counterfactual case, when we reduce the reward volatility, the chance that they're in habit mode does go up to around 18%. So we're able to kind of induce habit. This is partly sort of a sanity check. We're able to kind of induce habit mode by reducing the reward volatility variable. like increasing reward doesn't make them more habitual. It doesn't make them post, but it's because they're just computing the utility. It's not that they're like automatically habitized. So this is just a counterfactual thought experiment of what does it look like if you make people more habitual temporarily. It looks like this.
Can I quickly ask, given this volatility came up a couple of times, like there is this idea that people get more addicted, what I think is somewhat similar to creating habit, to
Yes.
rewards which are variable in nature.
Yeah,
And
yeah,
I guess in the model we assume it away when we create this.
Yes,
But I wonder
correct.
if there is a
Yeah,
way.
that's a very
just
good
one,
point.
What do you think about this? And second, like how can we include it?
Yeah. So what I think about it is I wish it was not true. Because it really goes directly in the opposite. And it is true that what's called partial reinforcement or stochastic reinforcement does generate stronger engagement. I mean, it's just an iron from casinos, rats, etc. And that's a real problem for these reward prediction error type models, because if the reward prediction error is moving around, like you get nothing, it should generate doubt and it will not generate habituation. And people have been thinking about this in animal learning for quite a few decades. So the typical patch is something like smoothing. You know, so you think about not likes on a daily basis, but like the last 1 week worth of likes. And there's some interesting data basically connecting George Lowenstein, Dražen Prelec, and others to Peter Diane. So there's some interesting data on what George and Dražen called savoring, which basically means even if you think there's a small chance of getting the reward, maybe there's utility from anticipation of maybe. It's like maybe is reward. And again, that's kind of an ad hoc way of just building in a utility from probably not getting reward, but thinking that you might, whether it's optimism or something like that. But you put your finger, you put your finger on kind of like a flesh wound. That's a big challenge for these models. The model is written down, goes in the wrong direction. And I've been talking to John O'Doherty a lot about that. And most of the animal neuroeconomics has just ignored, it's like, that's on our to-do list, but it's been on the to-do list for a while. So at some point you have to do it. That's a very good point. And obviously for technological design is very interesting too. Like if you want to get a rat motivated, if you can pay them, infrequently, that's even better, right? You don't have to reward the rat every single day. You reward them like more with a 10% probability. I wonder if the data on habituation and the nature of reinforcement.
Yeah, I wonder if there is a way to account for this by keeping track not only of the average reward you get, but also of the variance of the reward, and then allow for the same model where if the variance and mean of some weighted combination goes down beyond the threshold, then you stop accumulating habit. Something.
Yeah. There's a lot of. I mean, this is why we like math and mathematical social science, right? It's like you can look at the model and you can say, what do we put it here? What if we put it here? What do we put it here? And then try to find out. Yeah, so it could be that variance is rewarding, or it could be that you think of it like a bandit problem. I mean, another thing I'm fascinated by is skewness, right? So every animal that's been studied, as far as I know, loves skewness. And humans really love skewness, right? So it may be that this small chance of a large reward, even if it's more food than the animal can really have some special reward value. I mean, again, I'd rather this not just be an ad hoc thing I made up. It's something that has real biological depth to it and empirical robustness. But I'm going to start with some ad hoc. We usually start with some ad hoc thing we make up, and then, we kind of push it, try to make sure it's on the right track. Okay, and so these are some numbers I mentioned before, and you can see the late adopters. This is the percentage change from the beginning of the time when we see them in the sample to day 2000, simulated out. And you can see that for the early adopters, they actually do post a lot more at the end, and it's not influenced too much by these counterfactuals, a little bit by increased reward. And remember, the increased reward is temporary. It just increases reward during pandemic and it goes away, right? So this is the kind of residual effect of increasing reward. And the late adopters, there's not that effect, but is an increase in late adopters and also volatility reduction. There's a small lift. This is similar to the 5% of people in the London tube. This is the percentage of posting, rather the percentage change in the posting probability in the long run. So this is the best answer we have to, does the pandemic, create a new normal where people are posting more? And the answer is a little bit for the lates and a lot for the earlies. Okay, and just a summary, we tested this neural autopilot model. It has a lot of moving parts and also a lot of things that you can toggle and try to understand better. Thanks for your questions on that. The parameter values are okay, I would say, although the learning rate's lower than I would have guessed. We would have guessed 0.1 or something like that instead of 0.01. And there's some incremental fit beyond the choice persistence benchmark. And we are still looking at these counterfactuals and looking forward to Ryan's talk about tuna.
Cool. Thanks a lot. Very, very interesting. And I think we have a few more questions that maybe people may actually be able to ask live. But just one thought was around, you showed a bunch of this model fit, and I wonder if there's other moments that you look at that would be really useful, like just other summary statistics to see whether you fit them, like the, something like the distribution of days out of 7 that somebody posts on, which is something that a lot of these social media companies look at, is how many people are doing X action at least, 5 days out of 7 or something like that. Or other summary statistics, like given that you get a lot more likes, how does this affect your conditional probability of posting or something like that? And so I wonder if that's something that you've
we have not looked at that very carefully. We have looked at these kind of quantiles of a little bit. That's a good idea. Yeah, we certainly, and it'd be great to just know more about social media and say, what metric do you guys care about, and then just look at that metric, right? There's nothing wrong with that, right? It's one way to think about connecting practical concerns, with science. I think we did do. I think we did try some truncation where people who were getting huge numbers of likes regularly are kind of excluded, thinking that something fundamentally different is driving them. It adjudicate between habit and goal directed, right? It's just some separate data generating process, and that didn't make too much difference. They're pretty rare, but there's a lot of it. This paper may end up having a lot of robustness check appendices, right? Because you can think of a lot of ways in which the reward function is not picking up exactly what happens.
Cool. And I think we have Giovanni and Jason who maybe have a couple of questions as well.
Yeah. Thanks, Dean. Thank you, Colin, for the talk. I just had a quick question on the fit of the model. So if I understand correctly, the numbers that you presented were in sample. I was just wondering if you had any sense of what the ranking of the different models might be out of sample.
Yeah, I don't think we looked at that, which is unfortunate. I mean, we certainly have to. The way we specified the logit does have a few extra parameters, like a dummy variable in lockdown, and I think it's going to hold up pretty well, just guessing from the BIC and so forth. But I understand that's not the same as training and tests. That is a I mean, in general, I don't mind a model with a lot of free parameters as a matter of sort of taste, scientific taste, as long as I think they belong, or we should include them to see whether they're really necessary or not, So for example, in some of the theory work that Peter Landry did, that's in the chapter I mentioned at the beginning of the talk, we just fixed lambda r to equal lambda d, because otherwise it just becomes algebraically like incredibly messy. but it looks like in the data, they're just not the same. Stock adjustment is much more rapid, which was interesting. If that's generally true, that would be cool to know. But it's true in most of my own research, we're very sensitive about that in sample, out of sample, about overfitting. You know, we don't, I mean, overfitting is, happens a lot and it's bad. You know, and it can kind of lull you into thinking you really understand what's going on, and then you know you realize you've just overfit. And so, given that there are a lot of parameters, we need to check that and look more carefully.
Great, thanks.
No question.
Hi, I'm not sure if you can hear me. I don't have my normal headphones. Yeah, great. So I was wondering if maybe the fact that you have these 3 different outside parameters might actually be too flexible, because the outside options allowed to like immediately adjust on the day of the lockdown and when it's taken away. But I would imagine that like other things in the world also have structural dependence as well. And so maybe actually that flexibility is the reason why you're getting these unexpected lambda values for the learning parameters.
Yeah, it could be, because certainly the if the true lambda is much higher, which just means people are adjusting to likes history, and then you put in these kind of step function utilities, it could be that that's getting in the way. I think he may be working on this right now and just trying to you know, use fewer of these outside option utilities to see what happens.
Do you have another question from Ashwarya?
Hello. Sorry, my internet's super bad. Could you circle back to me in like 5 minutes? I'm really sorry.
Sure thing. Does anyone else have other questions?
I guess one question, I mean, maybe this is related to Jason's as well, is just the utility of the outside option and thinking about even actually quite allowing that to vary a lot in something like the Logit model. And just, I mean, I guess part of what I'm reacting to is it seems like it's really useful to have kind of a pretty serious baseline here against which to compare the habit model. And so are there other things that happen typically in people's lives that have sort of some inertia in affecting their outside options besides the lockdown, et cetera? And is there a way to incorporate that into maybe a baseline model, right? Like this week I'm on vacation. So then you would expect to see some inertia in my choices, right?
Yeah, in general, I mean, one thing we'll probably write about in our paper is what would be a better data set, you know, like an ideal data set that would have much more fine-grained data on choice sets and, you know, and option utility and so forth. We do, I think early on we did look at some provincial differences because there were lockdowns in some part of China and not others. And so there may be some information in that type of comparison. And there are other data sets. Yeah, I mean, there are a lot of data sets that came out about pandemic related behavior. I mean, as you know, there's been kind of a little tsunami of research on pandemic social science, sort of like an epidemic of pandemic social science. So there may be other data sets that would be much better than this. And I should add, related to that, so the ideal activity that would become habitized, I think, for humans in everyday life would be something that often involves very regular, like motor sequence. Phone on, and I check the Washington Post in the morning, and where we may also be able to measure these other things like response times, multitasking, and so forth. So Weibo's just is not ideal. It's just what we started with. Aishwarya is back.
Hi, Professor Camerer.
Hi.
We met in Barcelona in 2019. I'm not sure if you remember me.
Okay. Yeah.
Yeah. Kind of building up on your last point, I feel like most of the time when I'm checking Instagram, I'm not even kind of doing it consciously. Like I'm just like when the alarm goes off, the first thing I do somehow I find myself on like the Instagram
Wait,
app.
you wake up in the morning and immediately go on Instagram?
I mean, in the first 5
You need
minutes.
you need to see a healthcare professional. Hey, go ahead.
No, well, there's a message icon there. There's someone who's
Oh, okay,
sending
yeah. Right, exactly. It will notify you. Yeah.
And the meme is just like,
yeah. Sorry, go ahead.
The meme is just like a cat falling off the table, right? And then I like it without even kind of seeing the full video, and then I exit, and then the feed starts, right? And then on days when for example, like I'm waiting for something to happen, I feel like I go on Instagram way more. So I suppose a way to think about the pandemic would be just like this massive anxiety event that happened for everyone. And so, for example, in India, where I am right now, the lockdowns kind of were renewed 3 times or 4 times. So I wonder if, like, on the days that the lockdowns renewed, people just kind of got more anxious about their futures and went on social media far more out of just autopilot as a release for the anxiety.
Yeah. Again, we don't have the ideal data to study that, but it is true. There are pretty good studies involving brain imaging and also behavior that stress increases habit. Maybe through just cognitive load or something like that. Like it's either comforting to do something habitual, or it's low mental effort when you're worried. And I would say that's near the top of the list of things to try to study, because they're like, we have some data on like what Caltech students buy in the cafeteria, and we tried to understand habit in terms of like choice persistence and so on. And so you can use things like final periods, right? So Caltech students are sleep deprived almost all the time. They're like zombies. But during finals, they're really stressed. There's deadlines, and so it may be that they probably eat worse. First of all, they may be like eating their feelings, and they may eat more habitually, right? And some of that is just kind of cost of time, right? They have to rush in and rush out, and so they get what they got last time. But I think somebody's, if not us, somebody will do some great studies on that type of thing, where we're looking at, there are other state variables that seem to be associated with more habitual behavior based on very clear lab experiments. And again, I'm a little bit sour on using the pandemic to study social science, because there's so many confounds, right? It's not like one thing happened. It's like 9 things happened, and they happen very differentially. So unless you can, really measure stuff well, it seems like a weird thing to try to generalize from a pandemic about general human behavior in normal. Even though we have this pandemic paper of our own, so we couldn't resist. And also what you're describing is very much like what we think of as the psychophysiological markers of habit, right? Like automaticity, you can do 2 things at the same time. There's no attentional bottleneck. And actually we have a new postdoc coming who, I don't want to say too much, but he's got some really brilliant ways of trying to measure automaticity, like motor interaction with screens and things like that. So it can be done. It's just sitting there waiting for someone to do it in a clever, well-powered way, and that has some theory discipline behind it and not overfitting.
I just want to jump in and here and say we usually kind of mark at 1 that the kind of official session is over. But if there's conversation continuing, that's fine. But people may have to run. Some of my co-hosts have also had to go already. But if this discussion is continuing, that's fine. Just following up on what you just said, Colin, I think even that other example about finals highlights just how difficult it is to study some of this in the field, because you might get the opposite predictions, that finals period usually has people going on a different schedule than they usually are. And so it's actually a massive disruption to routine as well.
Yeah.
And so then you could get the prediction that, oh, this is going to mean that people are going to be less habitual. While meanwhile, you get this other prediction that maybe they're more habitual because of all this other stress and cognitive load, et cetera. So I don't know. I think that's just maybe a really challenging part of studying these phenomena in the field.
No, I absolutely take your point. I mean, I think this paper is sort of an example, right, where there's a lot of things we just can't be nearly as confident about as we would be even with other field data sets or with lab control. I am so bullish on field tests of neuroeconomics, but you really have to close the gap, right? So you either have to be able to measure more stuff in field data, or you have a kind of lab in the field, right? You do something experimental in the field where you do have a lot of control. And then you have to worry about selection, participant selection, and all the usual headaches. But there's so much interesting stuff from I'm writing a neuroeconomics book, and there's so much interesting stuff that's really well pinned down in quite artificial lab settings that I think we'll be able to see in field data. It's just a different kind of hard work. I mean, all research worth doing is hard in different ways, right? And this is just hard because you have to work around these identification problems and worry about what's exactly going on. And we use the heuristic almost exactly like you were talking about, Dean, which is the theory says X. Well, does the note, and then how do we clearly adjudicate those? And that's part of how behavioral economics has been successful. We have this mantra that the easiest way to win an argument is to run another experiment or run another regression. So you have to be like persistent, and then keep your eyes open for ideal data sets or partner with companies and stuff like that. Anyway, so if I was young again, well, I'd be trying to do the same thing, but I'd probably just have more energy and as many of you know, the ability to work in a scientific way with companies and governments has never been bigger. I mean, it's just unbelievable. When I was at my first major job was at Wharton Business School, and when businessmen would come, they would always give the same talk, which was, we hate government, they're keeping us from making money. And none of them had the slightest interest about investigating, like using their data or going inside their company. It was like we were spies. Like, we don't want you spying on our company, General Motors. Like, we have so much intellectual property. And now there's been a huge tidal wave. Some of that is behavioral insights has helped. Some of it is the culture of Silicon Valley, like business strategy as a hypothesis test, that kind of thing. Anyway, and marketing is great too, but you guys get to study like all the interesting stuff without the norm constraints of applied micro. So good for you.
Cool, thanks. And maybe that's a good place to wrap up for today. And I think it raised a lot of interesting directions from here as well. So
thanks for your comments. Thanks for making our to-do list longer. In a useful way. That's presented this. So